Okay, so let's get rolling. For starters, I put a reminder up on Slack and all the channels. The senior seminar presentations are tonight from 6 to 9:30 and tomorrow from 6 to 9:30 in this classroom and this Zoom classroom. And the topics and times are up there. I strongly encourage you to attend as many of the presentations as you can so you can kind of see what's coming up in your future, but also to support the seniors who are having to present in a less than normal circumstance without the audience and that kind of stuff. So hopefully we can have a decent sized room of people. We can fit 300, so invite your friends. In any case, that is tonight and tomorrow. So let's continue on where we left off. We did not have homework over the weekend. Let's see. Oh, this is 450 stuff. Okay, so. Dungeons and data structures. Ah, that's right. I gave myself some errors to keep us remember what we were doing from last time. Let's just quickly review here. So as of right now, I have created my objects for my student, my room, some doors. We are currently in the process of taking a door. So when we call our function called take door inside of room, we pass it a direction that we want to go. And we're going to go through our list of doors. So we have current number of doors in this room. So we'll say temp door is equal to, we'll go ahead and grab the door we're currently looking at. Now we're interested in whether or not that door has a direction that's equal to this direction. Let's look at doors. Doors have a direction to room A and a direction to room B. So we need to differentiate ourselves to decide which room are we currently in. So we're back here in room. So this is inside of a room. So we can go ahead and say room pointer current room is equal to this. All right, that is the current room we're in. I just went ahead and put it in a variable called current room, so we had a kind of a synonym, but the current room we're in is this. So we are asking this door to tell us its direction to the room that is not us. Okay, so what we're going to do is we're going to go ahead and teach a door a new trick. So let's see. Oh, we were starting to write get direction to other room given the current room. So that's inside of door. So we started writing that. Here we are. Get direction to other room. We pass it the room that we're currently in, and it returns the direction that isn't us. Okay. So if we passed it current room, and we're currently looking at room A, we pass it the direction to room B. So we will ask this door, we will say if temp door get direction to the other room. The other room is the room that is not the current room. Too many ends. All right, so if that guy is equal to the direction we're trying to go. So I've looked at a door, I've asked for the direction to the other room. If that direction is equivalent to the direction that presumably the user entered that they want to take, then we want to move. Well, what does this guy return? He returns nothing, but he's going to, well, we have to decide how we're going to actually make this guy work. So take door presumably means that whatever the player is going to go through this door and end up in this other room. Okay, so we need to get to the room that he's going to go to, because that's how we're using take door. Let me go back to driver and just see if we are already calling take door. We're not. We're adding student to the lobby. So then we're going to start asking the student what they want to do. The student will maybe say north, for instance, because I think we have, what does our map look like? We just created this little part of the world here, right? So he should see a north, a west, and a south. So if we say go to the north, he should take this door to the north. All right, so a couple things we can do. Let me look at what room holds. Does room hold a player? Does it have a list of inhabitants? What does this guy hold? Room HPP. He has the students. Right now there should only be a single student in there. So we could do a couple different things. I think if we want to ultimately have this guy be kind of a multiplayer room and have multiple students in here, we don't necessarily want to just go in here and remove bucket 0 and put him into the next room. We probably want take door to take in the student that we are removing. So let's go into door HPP. That's get door. Oh, it's in room HPP. So right now, take door takes in a direction. I'm going to also have it take in a student pointer, a student. That is the student who wants to take the door in this direction. So we'll add that to our implementation up here. All right, so now we have the correct door. And we want this student to go to that other room, okay? So getting the direction to the other room is going to give us our, this gives us the direction leading there, so we make sure that we've compared it to the direction we'd like to go. Now we actually need to get the other room. So room pointer, the other room is equal to, we now need to ask the door to get us the room in the other room. All right, so we need to get room pointer, get the other room. We'll pass it a room pointer to us. All right, so we'll pass in a pointer to a room, and this guy should return the room that's not us. Similar to this guy who returned the direction to the room that's not us. So we'll go and implement this guy. What was get door going to do? Do we remember what get door was going to do for us? Was that going to get us the room? I want to say that was going to do the same thing as what I'm about to write. Put a comment here. Anybody remember what we were going to use get door for? Or did we just put that there as a placeholder and didn't get around to it? Got nothing for me, Clancy?
Got nothing.
Nothing. All right. Well, since we don't know what it's supposed to be for, let's get rid of it. I have a feeling it was my mindset for what I'm doing here, where I'm getting the other room. So these two functions work together. One says, get me the direction to the room that's not me. This one says, get me the actual room to the room that's not me. Although, yeah, we're okay. That's for the door, because the door is a link between two rooms. Okay, so we'll do door CPP. We'll dump this guy. Get the other room is just going to ask the question if this, and this is a door function, if this room A is equal to current room, we're comparing those pointer addresses, then we'll return this room B. Else, return this room A. Now we can also write what's called an inline if statement. I think I showed you this previously in Java probably, but an equivalent to writing this would be, I'll take this guy here. So this does the same thing. Anybody remember me showing you an inline if statement before? It would have been in 250 when we were dealing with Java at some point. Is that something new, or have you seen it before?
I think it's something new.
Okay.
Yeah, I don't remember this. I don't understand why there's a question mark there either.
It's part of the syntax.
Okay.
This line of code does equivalent to this. So this is an what's called an inline if statement. So this allows me to ask, this is a Boolean expression. So the syntax for this guy is Boolean expression followed by a question mark, followed by what to do if it's true, followed by what to do if it's false.
Oh, okay.
All right, so this allows you to kind of have, like, for these one-offs when you're just doing a single thing inside of the if statement, you can say, you know, like in this case, I'm returning the result of this inline if statement. The result of this inline if statement, if this is true, will boil down to this value. If this is false, it'll boil down to this value. That makes sense? I would say it's not real commonly used anymore. It's something that's been around since C, so it's a syntax you might end up seeing. How about I go ahead and I'll leave it in there for our code here, just so you have a an example. Inline if statement. Something like this really it works well for, where it's just kind of acting like a switch. We know we're returning one of two values. It's either this guy or it's this guy, and it's going to depend on the result of this question. So that's kind of the go-to move for an inline if statement. But if you never use one in your entire life, everything will be fine. Because you can just write the if structure that we wrote there prior to this, and everybody will be happy. Okay, so maybe this knowledge is more for you if you're reading somebody else's code, and it might be an older program or one of those people who likes to show off and says, oh, here's a creepy syntax that's job security, whatever. You might run into something like this. So this is your little trivia nugget for the day. I would not test you over this or something. We'll talk about the exam next class, but and just the precursor is it's a usual Lippmann exam, 10 questions, whatever. It'll be online. You'll have the whole week to do it, but you have to do it all in one sitting. But you can decide when you want to sit to take the exam. It won't be at a scheduled time. Okay, so this guy is going to return the other room that is not this guy. Okay, so room A was that guy, we'll return room B. Otherwise, we'll return room A. So we'll go back to our room implementation here. And if we are inside of take door says, let's go ahead and get the other room that we want to go to. And that's going to come from temp door, get the other room given us. All right, so this is me. This is the room we're currently sitting in. Get me the other room that this door leads to. We're only in this if statement if we found the door in the direction that this student wants to go. So we'll get the other room. Now what do we need to do? We need to remove the student from the current room, and then we need to add the student to the new room. Well, we already have inside a room the ability to add a student. So we already know that last line of code, but we have to properly extract that guy from the first room first. So we can even go ahead and add that line in now if we trust ourselves. So we can go ahead and say the other room, add student. The student we're adding is a student. I'll put a little comment. So put the student in the new room. But before that, we need to remove the student from the current room. All right, so I need to get my student out of the current room. So we can go and teach rooms a new trick. Just like rooms know how to add a student, let's go ahead and teach them how to remove a student. Okay, hopefully we're really emphasizing this whole organic growth of our programs where we are teaching rooms tricks, we're teaching doors tricks. This is how your program can build up and have all these abilities. So we're going to say remove student. And this is the student we're going to remove. And then we're going to go and implement this little trick. So that in the end, even though we have this complex program, it's made up of a bunch of easy parts. And if you kind of think about what we're writing here, each of these little things is kind of like a question you might run into on an exam, right? Write a function called remove student that takes the student as a parameter and searches through a linked list of students and removes him from that linked list. Okay, so that's what we're dealing with there with remove student. So we'll go and implement this guy. This is from the room class. All right, and then as a reminder, rooms maintain a linked list of students that we want to remove this student from. So let's go back and look at our linked list of students. We do have a remove at index, and we also have an index of. So I can search through that linked list for the index of a specific student. Then I can remove him from the list. Okay. So remove student is first going to say, we're going to say int index of student is equal to this dot collection, where's my, the students, that's my linked list of students, dot index of, and I'll pass it the student we're searching for. So my linked list of students, that's what this guy is, has a function called index of that I can pass a student pointer to, and he will return for me the position in there where that student was found, or -1 if it wasn't in there. So if index of student is not equal to -1, that means I actually have somebody to remove. Then we'll say this, the students remove at index, index of student. Now, technically, this guy returns a student that we removed. We actually don't need to do anything with him because the guy who's reliant on this has the pointer to that student. We know who got removed. Okay, so we don't need to do anything with that. Now, one thing we could do, just so we don't, here, let me take you down the, let's call it the potentially problematic path. So we'll just do this right now. He's out of the list. The pointer to the student comes out of here. I'm not going to do anything with it because I'm returning nothing. So now when I go back to my door, where am I? Oh, it's in room, sorry. To remove the student from the list, I'll go ahead and say this, remove student, and I'll pass him a student. That's the student I want to remove. And then we'll go ahead and add the student to the next room. The problem with this is we are assuming that this guy works, that he does indeed remove the student from the room. If I go back, well, if I just scroll up here, I only remove him if I found him. All right, now we can take this a couple different directions. We can say, okay, one way or another, we have a student that wants to get into this door. Presumably, he only has access to this door because he's in the room that has the door. But if we don't get into this if statement, that means he actually wasn't in that room. So maybe we can decide this is some sort of superpower that the maybe the game administrator has, where he can kind of go through and just take doors willy-nilly, doesn't actually have to be in the room. So we can leave it in there from that perspective. Or we can have this remove student, instead of return void, he can return a student pointer. And as long as the student pointer he returns is a value, then we can say it worked. Similarly, we can have this guy return a int for whether or not it worked or didn't work. All right, so you know, we have bools in here where we can return true or false, and we can say if the student did get removed, then we'll go ahead and take him out of the room. We happen to know that, well, if we want to build in the flexibility here that anybody can take a door, we just want to make sure that a student isn't in two places at once. Therefore, we will do everything we can to remove him from the current room, whether he's there or not. And then we'll go ahead and put him in the room where this door leads to, knowing full well that 99.9% of the time, the student that is taking the door was in the current room and needs to be removed from that room before he goes into the next room, so he's not in two places. From the student's perspective, he wouldn't be in two places anyways, because as soon as we add him to the other room, when we add a student to a room, we are setting that student, we're adding the student to the front of our list. Oh, interesting. So when we add a student to a room, we'll go back to student here. A student is supposed to know about the room they're currently in. I don't see us ever setting that for our student. Presumably, when we, so we have a get name and we have a get current room. So we need to be able to set the current room for a student as well. So void set current room, we'll take in a room pointer, a room. And this is for this guy. And we'll just say this current room is equal to a room. So it's just a setter for that current room. And the reason we need to do that is inside a room, when we add a student to the room, we also need to say a student dot set current room to me. We let the student know that we have added him to us. Okay. And I think the reason we hadn't done that at this point is we haven't actually finished having students take doors yet. All right, so when a student enters a room, he becomes notified that the room he's in is his current room. So if I'm a student, I look around, I can see that, oh, I'm in a room. This is the room that I'm in. That's my current room. So we keep track of that, and we have the ability to be notified by a room that our current room may have changed or be initially set. Okay, so add student, goes ahead and adds the student to our list of students and then lets that student know that the room he's in is our room. Remove a student, this takes the student out of there. Technically, we could, if we wanted to be like complete here, we could say this, we could say a student set current room to nil. So we can erase his current room, letting him know that, look, we took you out of this room, so right now you're in limbo. So the student is in limbo. He isn't, as of this exact line of code, he is not actually in any room. He doesn't belong to any rooms linked list. He doesn't belong to, he doesn't know that he's in any room. This is like beam me up Scotty stuff. He's dematerialized and he's in the nether somewhere waiting to be put into the new room, which happens right here. So after we remove him and he's in limbo, then we immediately add him to the other room, and adding him to the other room will then set his room to the other room. Okay, so this is kind of our pseudo recursion, Noah, where we're calling, functions of the room class that we're currently in, but they're owned by different instances of the room. We're removing student from this instance of room, and we're adding student to another instance of room. That's why we are able to look at the code right here in this file, but they're actually owned by different instances of room. Okay, remove the student, add the student. Got it. Okay, so that should go back to driver. That allows a student to take a door. And take a door is part of, isn't it door HPP? All right, a room is able to display itself. I think we already showed that. So now we're ready to start adding stuff in to our game and actually make things move around. Because right now we've created all of our rooms. We've created all of our doors that link those rooms. We've gone ahead and added the student to the lobby, and we've displayed that room. So I'm going to go ahead and get rid of these other things here. And really what we'll do is we'll just say while Don. So while true, we'll go ahead and actually let's just do it once before we throw it in a loop. So we're going to go ahead and say the student get current room, which we happen to know is the lobby because it's the line right before it, but this is whatever room he's in. So the student get current room display. So we'll let the student go ahead and display the room they're currently in, and then we're going to add the code to ask them, hey, where do you want to go? Oh, this was actually kind of cool. In 450 yesterday, we wrote a file allocation simulator for the FAT16 file system in one class. It was a pretty cool project. So hopefully I see all of you in that class next what, spring? Let's see, where am I going? No, I need to go back another level. What am I doing? Dungeons and Destruction. Okay. G++. Star.cpp. Classroom has no member name, remove student. Okay, did I not put it in the HPP? Have remove student here. I must have forgotten to save something. Oh yeah, room HPP is not saved. There we go. There we go. All right, so there's our student's room. He's in the lobby. So now what we want to do is we want to ask the student, where would you like to go? So let's ask him once. And we'll have him go to the north and then display again, just so we can have a single move. And then we'll put it into a loop so we can run around our little world here. All right, so we'll go ahead and do a printf. Let's see, we're in C++, right? See out. Where would you like to go? And then we'll say string direction is equal to cin, hold on, sorry, string direction, then we'll say cin direction. So I'll read that in, and I'll actually probably put this guy up here, except I'm going to call this guy the command because we're going to expand it a little bit here in a few minutes. Just right now, we'll assume that all commands are directions. All right, so we read in the command, and then we're going to go ahead and say the student get current room, take door, and we're going to pass it ourselves. That's the who's taking the door, and the direction, which is our command. And presuming we put a real one in there, we'll go ahead and display his new current room. All right, so we'll ask him where does he want to go. Maybe he says, I want to go to the north. The north should put him in the server room. So then when he gets removed from the lobby, he gets added to the server room, then we're going to display his current room, which should be the server room. All right, is this saved? All right, where would you like to go? Let's say north. Ah, I'm in the server room. Obvious exits to the south. All right, so now we want to be able to run around in here and do all sorts of stuff. So we need to put this whole thing inside of a loop. So what we'll go ahead and do is, we have a couple different ways we can accomplish this. So I'm going to start our string command off as the empty string. And we'll go ahead and add the student there. And then we're going to say while command is not equal to maybe quit. Quit will be our way to get out of here. Then we'll display the current room, ask user what they want to do. And right now we assume they want to take an exit. And then once they're done, we'll do a little cout. Goodbye. Okay. So as long as they haven't typed in quit, which is not going to be the value the very first time through, we'll show them where they currently are, ask them what they want to do, read in what they want to do, assume that they want to take an exit, and then we'll have them take a door in that direction. Okay. All right, so here we are. We can go to the north. Now we're in the server room. We can go to the south. Should be back in the lobby. We can go to the west. We should be in Locklear's office. We can go to the east, back in the lobby. We can go to the south. Should be in esports. Go back to the north. We're in the lobby. We can go to the LOL. We're still in the lobby. Didn't actually go anywhere.
How come it says that Mr. Gonzalez is in there twice?
Oh, because we actually added him the second time. Remember that we'll try to remove him from the room?
Yeah.
But we still added him again?
Yeah. Okay, that makes sense.
But we are the same Mr. Gonzalez. So it's not another copy of him. It's the same pointer. He can exist in two places at once. It's a talent that Mr. Gonzalez has, I suppose. Okay. So that is getting back to what we had discussed. Maybe that's a reason to not actually add him to another room if we weren't able to remove him from the previous room, because he might be there twice. The other thing we can do is we can always, if we try to take an exit, we can always remove him from the current room and then add him to either back to the current room or, you know, I think what I had done, didn't I write a has exit for room? Maybe that's what that function I had in there was supposed to do. Whether or not it had an exit in a certain direction. But if we, so one thing we could do is we can do kind of our protection against this is we can go into our add student, and instead of always adding it to the front, we can check to make sure that student's not already in there. So if this Where am I? I'm in a room. So this, the student's index of a student is not equal to -1. Actually, we want it to be if it's equal to -1, meaning they're not currently in the room, then we will add them to the room and set their current room to this. This will take care of the situation where they're actually already in this room. If they're already in this room, we won't add them a second time, because this will return true if when we looked for them, it gave me a -1, which means they're not here. So I put them there. Go ahead and quit. So that got us out of the program. We'll compile it again. Ruh-roh. So that must mean adding him to the room the first time caused it to break. Does index of not actually return a -1? We pass on the student pointer. It goes through. If we find anything that equals that, we return the pause and return something that's greater than 0. Only here do we get something that is -1. When I add a student to a room, I go to my students, I ask its index of a student. Does index of work when there's nothing in the list? It doesn't, because this guy does not work for empty lists. Head is null the very first time through because it's an empty list. So if we could just ask a statement here, if this head so if not head, return. Technically, I didn't need the curly braces since I just have one thing. So if head is equal to null, meaning I don't have anything here, actually, I need to return a value. So I can return a -1. It wasn't found in there if it's the empty list. All right, so now he's in there. I should be able to go north. Then I should be able to say LOL and only still have one copy of Mr. Gonzalez. Okay, so, and then I can quit, so I'm out of my game here. All right, so that should be our working traversal mappy thingy. Okay, and I'll go ahead and upload that code. Now, what's the next thing we'd like to do inside of our dungeon? Right now, we can go and just walk around rooms. What's something else we'd like to be able to do in there? Maybe fight monsters? Well, we don't have strong feelings about this, apparently. Fight enemies.
Maybe like move like Mr. Gonzalez from room to room. So like if we don't want him in the lobby, we can move him in a different room.
Mr. Gonzalez is us.
We'll then move another student.
That's what we just wrote. is the move Mr. Gonzalez around stuff. Okay, so
No,
maybe,
like we're like you can pick up another student.
okay.
So like let's say that like you don't like somebody being in the room with you, you can pick them up and move them to a different room.
Okay. So we can have things travel with us.
Yeah.
Right. So if we have things travel with us, that's kind of like our inventory, right?
Yeah.
So we might have other objects in the room. So maybe there's a dry erase marker in the room. So another object in the room, and we could pick that up, which removes it from the room and adds it to our inventory. Something like that?
Yeah.
Okay. So to accomplish something like that, we might say that a student now also has a collection of, well, let's call it an inventory or a backpack. Students have backpacks, right? Backpack. So this is a collection of items. Okay, so what's an item? So an item probably has a name, that's a string. And actually for now, we can just say that's it. You know, items might differentiate themselves soon, and we might have weapon type items and keys and things like that. So, but for right now, a generic item just has a name. Okay, so we'll go ahead into here. Now, for a student, a lot of times in games we have a inventory max. So your backpack can only hold so many things at once. So we might say that we have a int max items, int current item. It's called max item count, current item count. So we would keep track of those couple of pieces of information to know whether or not we, because maybe we'll have an array of items that is capable of holding our max item count, but at any point in time, we have a current item count in there. All right, so let's go build our item. So we'll create a new file. This guy will be item HPP. And this guy will be a class called item. And I don't remember, did I do the if not include stuff? Yeah, I did. Okay, so here's our class item, and an item is going to have a string name. So we need to include string. And then because it's a string, we have to use namespace, right? All right, and this guy will have a private section, string name, public section. We'll have a constructor for a item that takes in a name as a parameter. And we don't need to be able to set the name because something's not going to have its name changed, at least not yet. Maybe later on, with our 1 day left of class, we can imbue an item with special magical powers, and its name might change to like the Flaming Sword instead of just the sword, something like that. But for right now, we're just going to give ourselves a getter for our name. So get name. And we'll go ahead and implement these guys. So I need my item.cpp. And this guy will include item HPP. And then we'll have that. Turn the name. Set the name equal to name. All right, so there is our item. So now we want to amend players, or amend students rather. Students now have a couple of other things associated with them. They have a backpack, which is going to be an array of items. And they're going to have a max item count and a current item count. So we'll have a int max item count, int current item count, and then we're going to have an array of, we need to include item. And then this guy will have a item. We call this guy the backpack. That's going to have some number of things in there. Is that how we? I think we're going to have to give it the memory. So we have an item pointer called backpack, which is going to hold the base address of our backpack. And then inside of student CPP, when we create our constructor here, we're going to say this dot max item count. Maybe let's set that to 10. This dot current item count is 0. So when a student is first created, they have no items. And then we're going to go ahead and initialize our array. So it would be this dot backpack. Can I say new item array this max item count? Will let me get away with that? No. And only let that if I have a, okay. So we need to include standard lib.h. And we're going to go ahead and create this array dynamically. So our backpack is going to be equal to Malloc. We're going to allocate some memory. How much memory? This times, or this dot max item count, times the size of an item. This closes. Might be assigned and then this guy is going to cast this to be an item pointer. Because it's going to come out of Malloc as generic memory. We're going to say it's actually a pointer to the beginning of a array of items. Have we looked at syntax like this before? We use Malloc?
We talked about Malloc, but we haven't really used it that much.
Okay. There might be another way around this with C++. There probably is, especially with a default constructor for items. But my issue here is inside of, and this gives us an excuse to look at Malloc anyways. So our issue here is that inside of our student header, when we defined our backpack, which we've decided is going to be a collection of items, we really want this guy, like if I had my druthers, let's say, we're going to say this would be an item backpack of size 10. If I knew what my maximum size was right then and there, I'm good. That'll automatically generate for me enough memory to hold 10 items. But because I didn't actually know what my max item count was going to be at this point in time, I couldn't actually initialize this guy to a value until we got to the actual implementation of the constructor. So instead, I said, okay, well, he's going to be an item pointer, because remember, the way that arrays work is an array, if we were to create an array in Java, so int array AR equals new int array 10, and then we were to print out AR, we'd get a memory address. The same thing is true in C++. How arrays work is they hold the base address of the array itself. So if I have a collection of 10 items, the array will hold the position in memory where that first item lives. And remember, items in an array live in contiguous memory. All right. So if I want to create let's say we want an item collection. Item pointer AR1. Actually, I'm going to do it this way. That line there and item pointer AR2 is equal to, I need to make it an item pointer, Malloc 10 times size of an item. These two lines do the same thing. They both produce for me, if I were to print AR1, this will give me a crazy memory address, which is the address of the item at bucket 0. This guy will also give me, AR2 will give me crazy memory address, which is the address of the item at bucket 0. Okay, but the difference here is that I use the array syntax to create this guy because I knew how many elements needed to go in here. This guy, I hard-coded that I knew it, but in our example over here, I don't actually know what max item count is yet. Therefore, I had to say, rather than using the built-in syntax, I'm going to go ahead and allocate my own memory. So this will give me enough memory to hold 10 items. This is enough contiguous memory. So Malloc stands for memory allocate. All right, so this will go out and find enough contiguous memory. This is equivalent to the new keyword. So this will find me enough contiguous memory to hold 10 of these guys. By default, Malloc returns a generic memory pointer, but I want it to be an item pointer. That way, when I when I say AR2 at bucket 3, it takes the appropriate size steps through memory. It'll take item pointer size steps through memory to get me to my the bucket I'm interested in. Okay, so that's how Malloc works. Both of these are going to produce the same animal for me in the end. I know this looks a lot friendlier, but behind the scenes, it's actually allocating memory just like this. I had to do it manually this time around because I didn't know about the 10 yet. I didn't know about the 10 here. So I had to say, instead of this guy being an item array, I said he's an item pointer, and pointers are equivalent to arrays. They're the same thing. That's what an array is. An array is a pointer to the first bucket of the array. And then inside of the constructor is where I actually gave him his value. So I created enough memory, and Malloc returns the base address of that. All right, questions about how Malloc works? So at this point, I can say this backpack at bucket 2 is equal to something. Because this syntax is the array syntax for walking through contiguous memory. And that's what I have right here. I have contiguous memory. I just built it in kind of an intimidating way, if you haven't seen it before. All right, so now we need to build into our student a function for add item. And this guy will take in an item pointer. Well, let's call it an item. Really, he should probably return a value whether or not our inventory is full, but given, oh, let's just do it the right way. So he's going to return a bool. So we'll say if current item count is equal to max item count, return false. It didn't fit. I'm overburdened. My backpack is full. I wasn't able to add it. Otherwise, we'll say this backpack at bucket, this current item count is equal to an item. This current item count plus plus. And I know that because we're in an instance scope, I don't have to say this dot here, but I prefer to always be explicit. That is, this is the current item count owned by this instance. So even though it's a little bit more verbose, I believe it's better programming practice. Or at the very least, it drills into your mind that I'm talking about a field here that is a variable owned by this instance as opposed to a local variable. All right, so if my backpack's already full, return false. Otherwise, add it, increase my count, and return true. So that's how we add something to our backpack. Now we probably also want a student to be able to display their inventory. So void display backpack contents. So this guy is going to loop through all of my, so for int I is equal to 0, I is less than this dot current item count, I plus plus. And keep in mind, we don't have the ability to drop items yet. Once we pick them up, they're ours. We super glued them into our backpack. All right, so go through our current item count, and we want to go ahead and print out all of our items. Where's my item here? So did we write get name already? We did. Okay, so back to our student. So for each of these items, we'll go ahead and say printf. No, we're in C++, not C. So C out, and I need to include IOStream using namespace standard. So we're going to see out this backpack at bucket I. This guy should hold item pointers. One moment. Where's my student HPP? Oh, so an item pointer points to an item pointer points to a collection of items. So this is a array where each bucket of the array holds an item pointer. That's the kind of value I'm storing. Which means then in my constructor, I'm not saying size of item, I'm saying size of an item pointer. And this guy is going to return for me an item pointer. That is an array of item pointers. That's what my array holds. It holds item pointer objects. So it doesn't hold the whole object, it holds a pointer to where that object can be found. All right, so that's what this says. This is an array of type item pointer, just like an int pointer would be an array of integers. All right, so now I should be able to say get name, and I'll put a carriage return at the end of each of those. So that's how a player will display the contents of their backpack. And they can add an item, for instance, if an item was in the room. For right now, we're just going to give them an item. So let's go back to our driver. And we'll go ahead and create a item. We need to include item HPP. So we'll create a item pointer called the chainsaw. That's what Mr. Gonzalez would carry. And so a chainsaw. And of course, his chainsaws are in a constant state of running. Go through a lot of fuel, actually. All right, so we're going to have a chainsaw, and then we're going to say the student add item chainsaw. Okay, and now inside of here for our command, we're going to have two different commands. We're going to say if command is equal to maybe backpack. Then we'll go ahead and say the student display backpack contents. Else, we must be talking about taking an exit. Any way you cut it, we're going to display our room. Then we're going to ask them what they want to do. So I cut too much stuff. There we go. So they either typed in backpack, which is going to ask the student to display the contents of their backpack, and otherwise we're going to have them take a door. So now we're supporting two different commands. Oh, sorry. Okay, so we'll type in backpack. And there we go. He has a running chainsaw in his backpack. Extremely dangerous. But the sign on the outside of the door does say no weapons on campus, I think. So that's why he has to keep it in his backpack. All right. So then if we were to add to this, we can still quit. We can now put items in the rooms. So now a room might also have a collection of items in it. These are things that are kind of strewn about the floor, maybe. You know, so, you know, he might walk into the room and there's an axe, for example, and he can then say pick up and then space the name of the item he wants to pick up. And he would then have a axe in the room. All right, so with that in mind, push this code up there for our final homework assignment. Add to Dungeons and Data Structures the ability for items to be inside of rooms and for students to be able to pick up items. A student should also be able to drop items in rooms, which would reduce the number of items the student has and add that item to the room's collection of items. All right, so now rooms can have items, students can have items, students should be able to pick up items, students should also be able to drop items. So if we just want me to summarize that. Rooms can have items, students can have items, students can pick up items, students can drop items. Out in the room, students can drop items in the room. All right, so presumably Mr. Gonzalez can run around picking up all the weapons on the floor around the computer science department and then go and drop them in the esports room so he has this nice like cache of cache of weapons when he wants to hold down the fort, I guess. Things took a turn there at the end, Clancy. So questions about what I'm asking you to do? And I gave you my code as a starting point, so you can either update your current code if you already have a good functional way down the path, or if you want, you can start with my code as your base. Just make sure you clone it, and then well, you would have to fork it first, then you can clone it. That way you own it and can push the the difference. Otherwise, you could just clone it and move the files over to your other directory where you have your Git repository. All right, questions, comments, concerns, bribes? Eerie silence. Okay, I will see everybody on Thursday. Hopefully, I see many of you tonight and many of you tomorrow at the senior seminar presentations from 6 p.m. to 9:30 p.m. Food and beverages will be provided. That is, you can watch me eat food and drink beverages. All right, have a good one.
Hey, sorry I didn't see your message until late last night. I wasn't home for a while, so I didn't get the chance to play some rounds.